If you look in the background of this video, you'll see this digit's actually counting to 12. Okay. Now, where I found the secret for the 12-hour clock was Indestructibles. Put in Indestructibles and 12-hour clock, and the guy actually has a schematic. And the unique thing about it is on the 7490 chip, if you can see this over here, there's zero. There are 9 reset. He takes one of these pins and he hooks it into the 0 set, and he uses an AND gate, a 3-legged AND gate, which you can make out of a 7408 by hooking the output of one into the input of the other one and tie the other together, whatever way you want to do it. But you can make a 3-input AND gate from a 7408. This video is not for people that just want to build a digital clock. This is information for someone that's at my level that decides they want to go back in time and build a TTL clock. But the indestructible guy figured it out. So in other words, you only need a handful of chips to make a TTL clock. Now, let me show you. This is basically how the clock that I built when I was in RCA. It was Charlie Trichel's circuit. It was wacky. He had a handful of chips just to do the 12-hour. And I said something to him and another guy, and they just stared at me with the look, well, if you can do better, you do it. But I kind of suspected that there was a way to do 12 hours. In other words, the clock goes from 1 o'clock at night, 1 o'clock in the morning, or 1 o'clock in the afternoon, all the way up to 12 midnight. So in other words, you get to 12 noon, towards 1 o'clock, 12:59, and then it goes to 1 o'clock in the morning. Okay, and a lot of the digital clock circuits out there give you 00 for 12 o'clock. All right, so Charlie Trichel figured out a way of doing it, and I didn't realize the clocks at that time read 12 o'clock or 00, or they were a 24-hour clock. So that he was very proud of the clock, and he didn't say anything to me. You know, he just gave me that look like you could do better, but I didn't understand digital logic at the level he did, and he probably thought. But this is basically the same clock. All right, the difference is the displays. They're old. Everything's old school. Everything on this board, in my hand, is 30 to 50 years old. Everything's been recycled. These are wire wrap sockets. They're on their 3rd project. And on the bottom, you see those capacitors? You put a capacitor, a 0.1 across each IC. And that's because as the IC switches on and off, there's little minute drops in the voltage through the wire wrap wires. And if another chip is in between, going between a high and a low, there's a little analog section right in there. And the glitches produced by another chip can then be counted right in that little point between where the chip is going from a 0 to a 1, or from a 1 to a 0, depending on the type of chip. So those 0.1s they're called deglitching caps. Now Charlie didn't have them on his circuit, and every once in a while the 12 o'clock circuit that he had built had some DTL chips. It would just any spikes on the line, you would come back and you'd see the clock is it'd be like at 15 o'clock or something like that. And I use giant doorknobs, RCA doorknobs, and this is just like the other one was. In other words, I can wiggle this. I can take the display off, and this display has resistors up in here, connector. I can change the display on the clock. So this will become basically a clock chip with a power supply. Now the power supply is very simple. It's got a 4-way bridge. You come into a 4-way bridge, and then you go to a capacitor. Then you go through a 5-ohm resistor at 3 watts. This is a 6-something resistor at 5 watts. Then to another capacitor, and then right to the circuit. And there's no regulator. It drops down with a certain amount of chips. It drops down in the area of 5 volts. Okay, and that's how everybody else did it. Now, to go from the take the 60 cycles signal, there's a 1K resistor that comes off the AC side of the full wave bridge, goes over to the 7490, and then from the top of the resistor to ground to protect the 7490 is a 5-volt Zener diode. Okay, you'll see a lot of people did that. Now the RCA circuit, he had an SCR in there, and when I worked on it, my circuit, I put a scope on it, and the SCR was never firing. What was happening is the resistance of the circuit was allowing the 60 cycle to get into the 7490, and that was making it work. And I said to Charlie, I said, you know that your SCR is never really firing, and he never thought to check it. So then the guy that worked with him came over to me one day and says, you know, you're right. The circuit works, but it's not working the way he thought he designed it. I said, yeah, that SCR is never firing. Well, over the years, they've eliminated all the different types of ways you could get that 60 cycle signal. Because you're using a 6-volt transformer on this, you can take the 1K resistor, go right over to the 7490 on pin 14, and it'll count, it'll work. Now, in order to protect the chip, you put a 5-volt Zener from pin 14 to ground. Okay, that's just in case any kind of surges come in or anything. It'll protect the chip. All right, but there were all kinds of ways. Now I used a chip that it was like an OR gate. It had 2 input OR gate. One leg went to one side of the AC of the secondary, and the other leg went to the other side of the AC, and it would put out a real quick spike. It worked really great. But I'm going old school. All right, everything on this is 30 to 50 years old. Those displays, those are the displays everybody was using on their digital clocks. Okay? There were no doorknobs, giant incandescent doorknobs. I had them on mine, and then I told you, I had it at the Radio Shack with me when I was working there. I sold it to a kid. He passed it off as his final project. And I went to that school to get more training, and then they said, let us show you what one of our A students made. And it was my freaking clock. And that's what brought back all the memories. I just happened to be up on the internet, and one of the videos recommended to me was a guy that used the damn doorknobs from RCA, the doorknob displays. And I contacted him, you know, and it seems that they did start producing them. See, when I was at RCA, I was there the last day. There was one more year after I was there that it was still open in Harrison. But this is how I built the other one that the kid got a hold. But this was longer. This was much bigger card, and but it's got all the nuances. The plug-in display where you could change the display out if you wanted to. My original power supply had a big honking. What was it, 7905, 7908? So anyway, it was a 5-volt regulator, and it had a big heat sink on it. Of course, it had more room. So basically, I had these wire wrap sockets I had salvaged, and even the wire. I'm resalvaging the wire. Okay, and I have all the power running to all the chips. And I got the first row of chips working, which divides the AC signal, which is 60 cycle, divides it by 6, and then 10, and this puts out a 1 pulse per second, which will go over here. These are the seconds. This clock doesn't do seconds, it only does minutes and hours, okay? So these are all 7490s. Now, a 7490 can divide by 6, okay? This book had a mistake in it. This is the NIMS Radio Shack. His divide by 6 had a miswiring. See, this is what I was telling you in one of my videos. Everything I'm touching, I'm finding mistakes. I kept seeing all these schematics that do 0, 0 instead of 12. And I'm saying to myself, I build the circuits and I'm like, why are they going to 0, 0? There's no 12. So I'm thinking it's me. And after about 4 or 5 times, and they were very sneaky to make sure when they took a picture of the clock, it was at 11 o'clock and not at 12 o'clock. And the wording in the description was, and then I found one where the guy cheated with the driver on a Nixie unit in order to get to 12 to read. And I was like, it isn't me. It's them again. See, I have a problem with the internet. Like, if you've watched my video just before this, you'll see a camera. I bought this new camera, and video camera, and it's dark. I took it out. It wasn't overcast this morning. It was bright overcast. And if you look at the video, it's very dark. And somebody said that the camera has very low volume and very bad on low light problems. So, but everybody else said how great the camera was. It was like those SDR radios. Oh, they're really good. I mean, I bought one. It sucks. Okay. Oh, now a year later, the guy's telling me, well, the one I got's really good. It's a year later or more. I have a different model. Your model should be better because it was a piece of shit they were selling. Well, the camera I bought's got great stabilization for bouncing, but it doesn't like low light. So I shot out there over to that strip mall that they're going to knock down, or they are knocking down slowly. And I knew it was the type of light outside where the sun was coming through the clouds real bright, and I knew the camera was going to have a problem. And then 2 weeks ago, the computer lost its battery, and one of the settings is messed up somewhere. It's not allowing the videos from that camera to play, even though it did. And it's somewhere in the auto detect for videos or whatever. I have to go looking for that now. But I'm getting deeper and deeper and deeper into the projects because bad information, mistakes in a book, okay? And I stay with stuff, and I'm like, I put hour upon hour into things. And it's amazing. Like if you were to build this project originally in one of the magazines, if you had put only some of the chips in, and you built it absolutely correctly, and you put a few chips in just to see if it's you'll fry the chips because there isn't enough chips to drop the voltage because it doesn't use a voltage rectifier regulator. See, this is the stuff I look ahead at. I go, well, I'll do a real quick test. I do a quick test, and the chip's getting almost 7 volts. But as you load up the chips, the voltage drops down to it's at 5.5 now, and I still have 5 more chips to put in. Okay, but I'm going through this step by step, and reusing the wire wrap wire. I'm not wrapping it a lot in order to salvage it, but I am soldering because these wire wrap sockets, they're on their 3rd project, and I got them salvaged off a project at work or off a computer at work, and then these are I used wire wrap sockets here, and in order to make it so this thing wouldn't be out too far, I put a gauge on the leads and I cut them, so they only stuck out of the perk board enough to put resistors on them, or one turn of or one connection of wire wrap. Okay, so I put a lot of thought into this. Like I said, Indestructibles, 12-hour clock. You may have trouble seeing his diagram. You click on his diagram, and then there's a little square on the diagram. You click it again, and that's the one you want to save. And good luck reading it. It's very tiny schematic, and when you zoom into it, it gets blurry. Okay, but he mentioned about the 9 set on the 7490, and that's what you're seeing working. I built that whole setup. I got the AC. I added AC to my my proto unit, which this proto unit's 50 freaking years old. You know, because I had a guy, you ought to use solderless perf board, or solderless. What's it called? Solderless proto board? Yeah, solderless proto board. I ended up long before you did, jerk. Okay, you're telling me stuff. Tell me something I don't know. Okay, tell me I'm a jerk. I already know that. Okay, that these people that make these comments, and I have to go and delete them in the morning, you know. But they're like, you ought to use this. You ought to make circuit boards and then give it out to everybody. No, if you go searching the 12 o'clock problem on the clocks, you got a bunch of people from that engineering country that turns out engineers like you turn out hot dog vendors. They run around asking everybody for the schematics. I'm telling you, it's Indestructibles 12-hour clock. Read the text, and you'll notice the guy mentions that the 9 set on the 7490, you know, and then 7490 divides by 6. The guy that built the clock, he's got a bunch of AND gates on his 7490s in order to make them count to 6. They count to 6 if you wire it up correctly. Okay, I noticed a lot of stuff. I'm like, why did he do it that way? But I fell into it. All I need is a schematic. I don't wire the clock up. No, everybody's clock went to 00, or it went to 24 hours. All right, nobody wanted to step into the puddle. Charlie Truchot stepped into the puddle in RCA, and he was proud of that circuit. Trust me, it was like 5 ICs that were TTL chips, and they would make that 7490 go from 1. What is it? It would start out. No, it would start out at 1 o'clock in the morning and go to 12. Okay, and that's what this is. That's 1 o'clock, 2 o'clock, 1 o'clock. Wait, I messed it up. 4 o'clock, 5 o'clock, 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10, 11, 12, 1 o'clock, back to 2 in the morning. Wait, 2, yeah, 1 and then 2. Right. It's confusing when you got it wired up, okay? And I put a few wires on this every day on this project, and it keeps me busy. When I start getting upset, like I have a friend of mine that thinks now he's seriously ill. I've lost almost all my friends. I've outlived everybody. And this one guy I keep in touch with, I went through prostate operation, and he wanted a prostate operation. Then they said his heart was bad, and now they're saying his PSA is high, and he possibly has cancer. That's where he's at now, and nobody gets back to him. I had told him my story years ago, that the doctors see you for like 7 or 8 minutes, and they tell you what they want to say, and then they're done. You say anything to them, it better be something really good, or they bat you off, okay? You know, all these commercials on television, they tell you how great the doctors are, and they're overworked, okay? You know, and you see these doctor programs like House, and Dr. Willoughby. Was it Willoughby? And yeah, you see them, and then you go to your doctor, and he looks like he's shot. And then he's got so many people he has to see in one day. Medicare doesn't pay him a lot for each patient that he sees. And out here, a lot of the doctors have switched over to privacy. They've gone private, and they have a certain amount of customers per year. They get more money than if they did Medicare people, and they're happy. Okay, a lot is changing. So what I do is I hide in these projects to get away from the nonsense. Oh, there's so much nonsense going on. Even like if you saw my last video, they're knocking everything down out here and putting up giant stuff, big box this and big hotels, and it's becoming like a Las Vegas Strip out there. And that's the way it's going. Everybody sees a way to make money, and they're going for it, okay? And you walk along going, gee, they did. Oh, and then the place I have Vietnamese girls cut my hair. I walk by that place. They're gone, okay? And I didn't go I didn't go soon enough, I guess, for the hair, or she's gone. The guy with the card place, baseball, he's gone too. So that mall's changing too. I got all these little strip malls and big shopping malls around me. And the one shopping mall at the top of the hill, the Rockville Mall, that's coming down to put housing up, multiple housing development thing, and not single-family houses. You're talking stacked chicken coop type houses, okay? And that's this place. And I came out here, and I was telling people it's really nice out here. You know, even the hotels are small. And 15 years later, this is like Las Vegas, okay? And the prices and stuff are starting to climb up, and it's not what I signed up for, as usual. I think that's it. All right, that's it. Ooh, and there will be no schematic.